Hai, Assalamualaikum. Jom kita revise sambil berehat. Sambil berehat pun kita boleh belajar tahu dengan tengok handphone. Apa tunggu lagi? Jom kita mula. Okey, untuk video kali ini kita akan mulakan dengan energy. What is energy? So, energy is defined as the system's ability to do work. Okay, so contoh di sini kita ada satu kotak yang akan ditarik oleh seorang student bernama Atan. So, the chemical energy from the student, let's say 2000 joule. And what happened when the student tried to pull the box with an external force of F? So, some energy will be transferred to the box. Okay, so bila energy transfer kepada kotak itu, so means that the box gain energy. So, bila box gain energy, W is equal to positive value. So, W equal to positive value means that work done on the system. Atan melakukan kerja, so energy is transferred to the box means that work is done on the system. Dan apa berlaku kepada kotak tersebut? Sudah tentunya kotak yang tidak bergerak tadi akan mula bergerak. So, there is a kinetic energy of the box when the box is moving. So, let's say the kinetic energy is 1500 joule and the box is moving to the left. But at the same time, there is a frictional force between the box and the surface, and the direction of the frictional force is opposite direction with the motion, iaitu ke kiri. So, what happen when there is a frictional force? So, apa yang berlaku? Kita mesti tahu that some energy from the box will transfer out to the surrounding. So, energy is out from the box. So, W is equal to negative value for this case. Jadi, apa yang berlaku? Energy from the system will transfer out to overcome the frictional force. Secara analoginya, chemical energy daripada Atan sebanyak 2000 joule akan ditukarkan kepada kinetic energy which is 1500 joule, dan another 5 joule will be transferred to the surrounding because energy is transferred out to overcome friction. Okay? Dan yang seterusnya kita akan tengok types of mechanical energy yang kita belajar dalam chapter 5. The first one, we call it as potential energy. And the second one is kinetic energy. So, potential energy is defined as the energy stored in a body or system because of its position, shape and state. Manakala kinetic energy pula adalah the energy of a body due to its motion. Nak senang ingat, bila objek bergerak, dia akan ada kinetic energy. Dan kita tengok pula potential energy, kita bahagikan kepada dua perkara, iaitu dua jenis potential energy. The first one, we call it as gravitational potential energy. And gravitational potential energy is related to the energy stored in a body or system because of its position. Jadi, macam contoh dalam gambar ini, kita ada sebiji bola yang dipegang oleh N pada satu ketinggian yang kita label sebagai H. Dan bila bola itu berada pada satu position or at certain height, kita katakan bola itu ada potential energy. So, the equation of the gravitational potential energy U is equal to mgh, where U is the gravitational potential energy, M is the mass of the ball, G is the acceleration due to gravity, which is 9.81 meter per second squared, H is the height of a body from the initial position. So now, look at the second type of potential energy. Dalam chapter ini, you akan belajar berkenaan dengan elastic potential energy. Apa itu elastic potential energy? So, elastic potential energy is defined as the energy stored in elastic materials as the result of their stretching or compressing. Contoh paling mudah, elastic material yang kita jumpa dalam chapter ini adalah spring, because spring is one of the material that can be compressed or stretched. Atau yang kedua seperti gelang getah ataupun elastic cord yang boleh stretch ataupun compress. Jadi itu adalah contoh benda yang boleh stretch ataupun compress dan boleh ditanya dalam soalan berkaitan dengan elastic potential energy. Jadi sekarang cuba tengok contoh ini. Spring yang berada di bawah itu merupakan initial condition of the spring. Maknanya dia belum stretch ataupun compress. And what happened when we put an applied force FA to the right? Dan bila kita cuba tarik spring ini ke kanan, so there is a restoring force where the direction of the restoring force should be opposite direction with the applied force. Kalau tarik ke kanan, direction of the restoring force mesti ke arah kiri. Kenapa? Sebab bila kita remove applied force, kita cuba lepaskan spring tadi. So what happened? So the spring will come back to its original length. So macam mana dia boleh kembali kepada bentuk asal? So the restoring force which is to the left, we try to put the spring into its original length. Dan bagaimana pula jika kita cuba untuk compress spring tersebut? So, let's say we put an applied force to the left, kita cuba tolak spring tadi dan spring itu akan compress. So, what is the value of X? Macam biasa, in this case, L final lebih pendek daripada L initial. So, when L final minus L initial, when the spring is compressed, so the value of X would be negative value. Tapi bila spring itu stretch, the value of X akan jadi positif kerana L final lebih panjang daripada L initial. So L final minus L initial is equal to positive X. Dan bila kita cuba kompreskan spring ini, and we put applied force to the left seperti yang ditunjukkan oleh arrow yang berwarna merah, so automatically there is a restoring force Fs opposite direction dengan applied force tadi. Boleh? Jadi situasi ini kita boleh kaitkan dengan Hooke's law, where Hooke's law states that force Fs of spring is directly proportional to the amount of stretch or compression, atau kita panggil sebagai extension or elongation X if the limit of proportionality is not exceeded. So, contohnya kita tarik spring itu lebih panjang, so the value of X is increasing, so means that Fs, the restoring force, also increasing since Fs is directly proportional to X but opposite direction. Kalau nilai X besar, Fs pun akan besar. So we can write the equation of restoring force is equal to negative kx. So negative showing you that the direction of the restoring force always oppose the direction of x, seperti yang telah kita bincangkan sebentar tadi. Dan jangan lupa k is the spring constant. Jadi sekiranya kita ada satu graph, iaitu graph of F as against X. So remember, area under the graph is actually equal to the value of the work done to compress or stretch the spring. Atau kata lainnya, area under the graph of F against X, we can relate with the elastic potential energy of the spring. So by referring to the graph, so we can calculate the area under the graph is equal to half times F times x1, di mana F is equal to kx, dan bila kita gantikan dalam equation, kita akan dapat satu equation W is equal to half kx squared. Therefore, we can relate that area under the graph is equal to elastic potential energy. Jadi jangan lupa, equation elastic potential energy is equal to half kx squared, dan equation untuk restoring force Fs equal to negative kx. Jadi sekarang kita akan beralih kepada jenis energi yang kedua, iaitu kinetic energy. Contoh dekat sini ada sebuah bas dua tingkat that is moving to the right with the velocity of v. So bila bas ini bergerak, kita boleh katakan bas ini ada kinetic energy. Alright, so remember the equation of kinetic energy is equal to half mv squared. Saya pasti semua pelajar boleh ingat equation kinetic energy equal to half mv squared. Jangan tertinggal squared tu, sebab ramai pelajar akan tertinggal squared bila menulis equation kinetic energy. Sekarang jom kita teruskan revision kita dengan tajuk conservation of energy. Ingat lagi tak? So definition of conservation of energy state that in an isolated or closed system, the total energy of that system is constant. Okay, maknanya dalam closed system, so the total energy of that system is constant. Jadi kita boleh tulis sebagai total initial energy is equal to total final energy. Sekarang saya akan bagikan conservation of energy into two parts. The first one is conservation of energy with dissipative force. Dan yang kedua, conservation of energy yang berkaitan dengan mechanical energy. Dan jangan lupa dalam chapter 5 ini kita lebih fokus kepada conservation of mechanical energy. Tapi tak apa, kita akan tengok dulu apa yang dimaksudkan dengan conservation of energy with dissipative force. So dissipative forces such as friction, air resistance, ataupun case di mana push or pull by a person do not conserve mechanical energy. However, when these forces are taken into account, the total energy is still conserved. Ingat lagi tak atan tarik kotak? So the total initial energy, which is the chemical energy, is equal to 2000 joule plus negative 500 joule. Di mana negative 500 joule adalah jumlah energy that transferred out to overcome friction. So what is the total final energy? So the total final energy is equal to kinetic energy. So kinetic energy is equal to 1500 joule. So ini adalah contoh ringkas berkenaan dengan conservation of energy with dissipative force. Tapi jangan lupa, dalam chapter ini kita lebih fokus kepada conservation of mechanical energy. So the definition of conservation of mechanical energy state that in isolated system, the mechanical energy of a system is the sum of its potential energy U and the kinetic energy K of the objects are constant. So we can write the equation as total initial energy is equal to total final energy. Dan di sini saya bawakan satu contoh di mana kita ada satu bangunan dengan ketinggian of H dan sebiji bola berada at the top of that building. Jadi sebelum bola ini jatuh dan bergerak ke bawah, so bola ini dikatakan mempunyai gravitational potential energy due its position. Okay? Dan bila bola itu mula bergerak jatuh ke bawah, so bola itu dikatakan akan mula gain kinetic energy. And before the ball touch the ground, so there is a velocity of V. So at the final position, we can say that the ball has the kinetic energy of KE, but the gravitational potential energy at that point, selepas dia jatuh dari ketinggian H tadi, so at final position, the ball has the kinetic energy. So bila kita tulis in terms of conservation of energy, total initial energy is equal to total final energy. So initially, the ball has no kinetic energy. So we can cancel out K. At final position, the ball gain kinetic energy but reduce its potential energy. So at final position, no high. So means that the gravitational potential energy of the ball at final position is equal to 0. Jadi kita boleh cancel siap-siap. So kesimpulannya untuk kes di sini, potential energy transform to kinetic energy once the object is released from the certain height and start to move downward. Okay, contoh yang seterusnya, let's say we have a ball at point A and V at point A, which is initial velocity at point A is equal to 0 meter per second, and then the ball is moving until it reach point B and then point C. So at point B, bola itu ada velocity V1, at point C, bola itu ada velocity V2. So remember, at point A, the ball is not moving, so no kinetic energy at point A. Jadi, jenis tenaga yang ada pada point A hanyalah gravitational potential energy U equal to mgh. But once the object start moving until point B, bila dia berada pada point B, look at the diagram, the position of the ball from the ground. So the ball at a certain height of H2, dia ada ketinggian, means that at point B, the ball still has the potential energy U, dan dalam masa yang sama dia sedang bergerak so the ball has kinetic energy at point B. So we can write that total energy at point B is equal to gravitational potential energy U plus kinetic energy. And then when the ball is moving until point C, so at point C, no height of the ball, so the total energy at point C is only equal to kinetic energy because the object is still moving at point C with the velocity of V2. Dan subtopik yang terakhir dalam chapter 5 adalah berkenaan dengan power, where power is defined as the rate at which work is done. Bila ada perkataan rate dalam definition, kita akan kaitkan dengan sesuatu perkara bahagi dengan masa, which is T. So in this definition, power is defined as the rate at which work is done. Means that power is equal to W, which is work, divide T, which is time. So power is equal to W, which is work, and it is the amount of energy transferred. So bila sesuatu sistem atau objek melakukan kerja, means that there is an amount of energy transferred. So W is work. So work is the amount of energy transferred. Since work is the amount of energy transferred, we also can define power as the rate of energy transferred. Jadi equation power juga you akan jumpa P is equal to E over T since power also defined as the rate of energy transferred. Okey, sekarang kita tengok analogi di sini. Kita ada dua orang pelajar yang cuba tarik satu kotak yang sama. So we have student A and student B. Alright. So let's say both students are doing the same amount of work to reach the finish line, where it is given that W is equal to 100 joule. Now look at the time taken for the students to arrive the finish line. Let's say student A arrived at the finish line in 60 seconds, while student B arrived at finish line in 90 seconds. So based on these two situations, we can calculate the output power of student A, where the output power PA is equal to 1.67 watt. And for student B, we also can calculate the output power for student B, where the output power for student B is equal to 1.11 watt. Jadi dekat sini kita boleh lihat jika kedua-dua pelajar melakukan kerja yang sama iaitu 100 joule, tetapi student A boleh melakukan kerja itu dalam masa 60 seconds dan student B boleh melakukan kerja yang sama dalam masa 90 seconds. Jadi, output power siapa yang lebih besar? So, based on the calculation, we can say that output power of student A is bigger than output power of student B. Boleh? Seterusnya kita tengok dua equation yang berkaitan dengan power dalam chapter ini, iaitu yang pertama adalah average power, where the equation of the average power is equal to delta W over delta T. Dan yang kedua adalah berkaitan dengan instantaneous power, where instantaneous power is defined as the instantaneous rate of doing work. Okay, so bila kita derive equation power is equal to dW over dt, so we can try substitute W equal to F dot S and we rearrange the equation. Jadi kita boleh tulis balik instantaneous power is equal to F dot ds over dt, di mana ds over dt is equal to velocity v. Dan akhir sekali, kita boleh tulis equation of instantaneous power is equal to fv cos theta. Remember, where v is the magnitude of velocity, f is the magnitude of force, and theta is the angle between f and v. Jadi sebelum video ini berakhir, jangan lupa power is a scalar quantity dan unit untuk power adalah joule per second or W, which is watt. And remember that 1 horsepower is equal to 746 watt. Dan itu saja untuk video kali ini dan pesanan saya, selamat berusaha dan semoga kita jumpa lagi dalam next video untuk buat lagi beberapa examples berkaitan dengan chapter 5. Jumpa lagi. Bye-bye.